So what I've put up here are what are called the laws of exponents, and they define how exponents behave. So the first one is a to the x times a to the y equals a to the x plus y. Let me just put up an example of each of these. So in the first case, if we had 2 to the 2 times 2 to the 3, that would equal 2 to the 5. If you think about it, this makes sense because 2 to the 2 is 2 times 2, and then 2 to the 3 is 2 times 2 times 2, so it makes sense that that would be 2 to the 5. Next example is a to the x over a to the y equals a to the x minus y. So let's try that one. Let's suppose that I have 2 to the 5th over 2 cubed. So that's going to equal 2 times 2 times 2 times 2 times 2 over, write that 2 a little neater, over 2 times 2 times 2. And you'll see that we get these cancellations leaving 2 times 2, which is 2 to the 2. In other words, 2 to the 5 minus 3. Okay. 3, a to the x to the y equals a to the xy. So the example here would be 2 to the 2 to the 3. That should equal 2 times 2 to the 3, which is 2 times 2 times 2 times 2 times 2 times 2, which is, that's 2 to the 6th, which we can easily see is in fact 2 to the 2 times 3. So that law works as well. Let's do number 4. A to the x times b to the x equals ab to the x. So here we can say, let's say 2 to the 4 times 3 to the 4 should equal, does it equal 6 to the 4? And the answer is, of course, it does, because we can go 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. And since multiplication commutes, if we just regroup, we get 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. And that clearly equals 2 times 3, or 6, to the 4. And now let's just put up an example of number 5. If we have, let's say, 2 to the 3 over 5 to the 3, that equals 2 times 2 times 2, 5 times 5 times 5, and that equals clearly 2 over 5 to the 3. So that rule works as well. One of the rules that we use kind of extensively in calculus is the rule that you can convert a radical into a fractional exponent. So for example, we know that the square root of x is equal to x to the 1/2. We make extensive use of this sort of rule. Now you might wonder why this is, and it's useful to just go over that in terms of the law of exponents. So let's suppose that, well, actually, let's just write it this. We know that root 3 times root 3 is equal to 3. So in other words, the square root of 3 is simply defined as a number such that I can multiply it by itself and get 3. Well, let's think about how this works in terms of the law of exponents. So if I write 3 to the 1/2 times 3 to the 1/2, by the law of exponents, that should equal 3 to the 1/2 plus 1/2, which equals 3 to the 1, which is 3. So in other words, this is a number that I can multiply by itself and get 3, and this is also a number that I can multiply by itself and get 3. Therefore, it sort of stands to reason that these must be equal to each other. So that's how we get that the square root of 3 is equal to 3 to the 1/2. You can try this yourself. For example, you might consider trying the same exercise where you use the law of exponents to verify that 5 to the 1/3 is actually equal to the cube root of 5.